Okay, the mandrel is glued in with super glue, and it goes right inside the full 2 inches 50mm. Unfortunately, I don't have a taper turning attachment. Neither can I move the tailstock to one side. The only way I can turn a taper is by moving this cross slide. And to give clearance for the handle, I've got to have this very long cutter. Now I've got to turn by hand. There's no way I can power this one. So it's going to be a long, slow process. And we'll see what happens. There it is, finished. Not too long a job after all. Anyway, next part of the job is to cut this bit off. Difficulty there is I can't use the lathe to do that. That's got to go in the milling machine. The other problem with it is it's actually not flat. It's got a camber on it. So I'll have to put the camber in at a later stage. For at the moment it's just going to be cut flat. Right, this is the setup. It's set at 28 degrees and I use this little setter which works in tenths of a degree, so I'm pretty sure I'm on 28. I use the edge of the table and the edge of the V-block that it's clamped to, and I'm fairly confident that it's 28 degrees within a tenth or so, which should be enough. Now this is a CNC machine and doesn't have any handles. I can do it manually with this device. You just turn the handle for X, Y and Z. However, as it's a CNC and it's a slow business, doing it by hand, a simple program should enable it to cut through without any trouble. Okay, let's set it going. Normally, when cutting a slot, the cutter would lift off and return to the start. The trouble with that is it takes a long time to lift off and go back to the start and do it all over again. So instead of a slot, I've told it it's cutting a profile. So although the cutter is 7mm wide, it's actually cutting a slot 7.1mm wide, and that avoids this lifting off at the end of each cut. feed rate is 200 millimeters a minute, and the plunge rate is 100. Well, that's it finished. I finished it off by hand. I needed accurately to the 42 millimeters at the side there. The reason I chose a 7 millimeter, which was an odd sort of size, was because it was the smallest with enough reach to get right through for the cut. Okay, next job, I'll try and show up this side of the mouthpiece. It's got a flat on it. So now I've got to cut one on the opposite side to the one we've just done. So it's all down here, and it's the place where the clarinet reed will sit so that it can vibrate. So it's the same setup on the milling machine, only this time it's a smaller cut, and I should do this one by hand. But this was rather tricky because the taper is 6 degrees, but this flat is actually 6.2 degrees. So how accurate I've got the 0.2, I'm not too sure. The important thing is the width across there. It should be 13 millimeters when I've finished. Anyway, let's make it. I've made several cuts, so let's make another one. Doesn't look much of a taper on it. I'll try one more, cutting the other way. I'm only using very small cuts. Okay, I think I'll just check the measurements there and see what the taper's like and reset if necessary. Well, the problem seemed to be one of deflection. Whether it was in the cutter or not, I don't know. Anyway, I changed the cutter for a 12mm and up the rev count to 15, 2000, something like that. It seems to be alright, but it's nowhere near the angle I set it at, which was supposed to be 6.2. It's more like 6.5 before I got the measurements I finally wanted. This is the end of the easy stages. The next stage is considerably more difficult.